So, how well do thermal pads work? Today we're looking at Grizzly's Carbonaut and KryoSheet thermal pads to see if they're a good alternative for thermal paste. Stay tuned. So we spent several videos looking at how to cool down an AM5 Ryzen CPU. During that time, I had purchased both of these thermal pads here and meant to do a video on them. Unfortunately though, they ended up getting tossed to the side and that video was never made. Primarily because we ended up solving our temperature issues with that system. But I still have these pads and I'm kind of curious as how well they work. So today, we're going to find out. We're going to be looking at both the Carbonaut reusable thermal pads as well as the high performance KryoSheet thermal pads. We're going to find out if it's worth paying the premium for the Carbonaut or KryoSheet pads, and if we're going to see both of them and compare them to Grizzly's regular Hydronaut thermal paste. Also, I'm going to try to pronounce all of the different names of these products correctly and probably fail most of the time. In fact, I probably already failed a few times. But before that, I got to pay some bills. So check out today's sponsor. Is your copy of Windows 10 unactivated? Well, it doesn't have to be, because with today's sponsor, VIP SCD Key, you can get a valid Windows 10 license for under $20. Stop dealing with that stupid watermark on the desktop, the valid license for Windows 10. Also, with an activated copy of Windows 10, you can upgrade to Windows 11 for free. Just go to the link in the description below and pick up a valid Windows 10 license key. During checkout, use the code CYBERCPU for a 25% discount. Once you have your key, go to your activation settings in Windows 10 and click on the link that says Change Product Key. Enter the product key you just purchased and hit Activate. Now you don't have to deal with that stupid watermark that come with running an unactivated copy of Windows 10. Now, on with the video. So some type of thermal solution is required when mounting a cooler onto a processor. The reason is because the IHS on a processor and the surface of the cooler is not perfect. And you know what? It does not matter how polished these two surfaces are. They're still going to have microscopic blemishes on them. And these microscopic blemishes are going to contain air pockets. And air is a horrible thermal conductor. So to solve this problem, we typically use thermal paste to fill in these voids. However, thermal paste has some drawbacks. One, it's messy. For anyone that has repasted a CPU before, you know if you get thermal paste on your hand or other components, it's kind of hard to clean up. And some thermal paste is harder to clean up than others. Yeah, I'm looking at you, Arctic Silver. Another problem with thermal paste is that it doesn't last forever. The efficiency of thermal paste is based on its ability to stay in some kind of liquid form. So it can fill those voids. When the thermal paste dries up, its ability to fill those voids diminishes greatly, if not completely. In fact, sometimes it can actually create voids that weren't there before. I've had several instances recently where I've had to repaste older AMD FX processors on customer systems that I built a decade ago because they started overheating. In every single case, that overheating was due to the factory thermal paste that comes on AMD heatsinks simply drying up and no longer transferring heat between the IHS and the heatsink. Now, to be fair, in those cases, the factory thermal paste lasted a long time. However, it's not uncommon for me to repaste the CPU in one of my systems annually when I flush and clean out the cooling system. However, both of these problems are solved with thermal pads. Thermal pads are not messy at all because they're just pads, and thermal pads don't dry up. They can essentially last the lifetime of the system. That is, of course, if they're left alone. Today we're looking at two different thermal pads. We're looking at Grizzly's Carbonaut, which is a reusable carbon-based thermal pad, and we're also looking at Grizzly's KryoSheet, which is a non-reusable graphene thermal pad. Both of these two thermal pads have positives and negatives. For one, the Carbonaut pad is reusable, which is kind of a huge plus. However, the KryoSheet pad has a high thermal conductivity that's supposed to make it better performing pad, but you can only use it one time. They recommend replacing it if you ever remove your cooler. which, by the way, is a claim that we're going to test today. And when it comes down to it, the Carbonaut pad, even though it's reusable, it's also cheaper. The 38 by 38 that I got here for the AM5 Ryzen cost about $19. The KryoSheet pad, on the other hand, is not reusable and it cost $22. So even though these prices don't seem very far off from each other, the fact that the cheaper one is also reusable and the more expensive one is a one-time use, if you take the cooler off often, those prices can differ greatly. So does that price per performance make it worth it? Or is it better to go with a cheaper reusable thermal pad? That's one of the questions that we're going to be answering today. We're also going to be putting all this up against Thermal Grizzly's Hydronaut thermal paste, which is a great thermal paste in and of itself, but it's still affected by the downsides of thermal paste that we spoke about before. Also, this thermal paste isn't cheap either, but it's considerably cheaper than these thermal pads. A 1 gram tube of Thermal Grizzly's Hydronaut is about $7 on Amazon. And this 26 gram tube I have is about 40 bucks. However, this tube is good for countless applications. And I buy these because I use it kind of a lot. But you're just maintaining one computer at home, then you probably don't need a 26 gram tube. An 8 gram tube sells for about the same price as one of these thermal pads, and you can repaste quite a few computers with an 8 gram tube, and they go for about $22. So before we can test all this out, we need to actually install one. So let's get this system right here torn apart, and I'll show you how one of these are installed. So these things aren't really hard to install, but one of the things that I'm gonna have to do in mine is I have to remove my GPU, primarily because the wires for my CPU block go underneath the GPU. So I'm gonna pull that out real quick, and I'll probably save you the time of having to watch me pull a GPU out, because this GPU, because of the AIO that's in here, is kind of a pain in the butt to pull out. So it's gonna be out right now. Okay, so now that that's out of the way, we're simply going to disconnect our RGB and our power, and we'll start pulling our cooler off. And for this system here, because it's AM5, it's just 4 screws, and I typically take these screws off just like you would a tire on a car. You just want to kind of stagger across it so it doesn't have uneven pressure on the CPU. So you take it off a little bit at a time here. And what you'll notice is once I pull this off, it's got heatsink compound on it. And this is one of the downsides to heatsink compound, is that it's a mess. That's one of the biggest benefits that I think that we get from one of these sheets. So once we get these screws out of the way, we can pull the cooler off. And as you can see, it's a mess. So yeah, ultimately, when it comes to thermal pads, this right here is the reason why I wanted to test these sheets, because cleaning this stuff up is kind of disgusting. And especially on an AM5 processor, it becomes really messy. So to clean these off, essentially what I use is a fairly clean rag. Well, this rag has been used to clean quite a bit of compound off, but that's okay because it's better than wasting a good rag every single time you do it. I typically keep one around that I use to clean compound off until it gets so filthy that you can't find any clean spots on it anymore. And when that happens, then I typically get a good one. And I usually just wipe it clean until there's no more sign of heatsink compound on it. And then at that point, we move on to the processor itself and we start cleaning it off. And the nice thing about one of these secure brackets, and we did a video on these secure brackets a while back, is it really does make it easier to clean compound off because it doesn't get into all the little crevices of the AM5 processor, but it still makes a mess. As you can see, it's still quite dirty trying to get it clean. And ultimately, once I'm done here, I'll probably have thermal paste all over my hand too, which makes it fun to clean up. And if you're having problems, a lot of times with the Thermal Grizzly thermal paste, you can just wipe it off. You don't need to use any kind of chemicals to wipe it off. However, if you're using some thermal compounds, require quite a bit more cleaning. And with those, you can actually use some isopropyl alcohol on it. Just make sure not to make too much of a mess of it. But for the most part, after you get the majority of the compound off, you should be okay to go. And there you are. So the pads themselves, once you open up the package, come in these little boxes. The KryoSheet is a lot more high-end than the Carbonaut, but it's cheaper too. And to open these up, essentially you just open it up, kind of like a jewelry box, kind of. And then inside, you take the first piece of foam off, and you'll see it has the sheet itself is wrapped between two pieces of plastic. Now, on these ones, the plastic came out. Normally, they're sandwiched just like that. And that's to kind of stop the sheet itself from getting bent or distorted when you're trying to take it out of the box. But to pull it out, we just kind of take the plastic out just like that. And as you can see, it did come apart. But the pad itself looks like it's in good shape. So we're just going to take the pad and trying not to get any oils from our finger in between the pad or the CPU. I'm just going to kind of use my fingernail to draw this thing off of the plastic. And then set it down right on the pad. And then we'll kind of line it up with the CPU itself. Just like that. And then once we get it lined up, we can go ahead and reattach our cooler. And for that, it's just the reverse of putting it on. However, what I would recommend is once you set it down, you don't want the cooler itself to shift in either direction because it could shift the pad underneath it. So once the CPU cooler is stationary on top of the processor, you want it to move as little as possible. So I'm going to hold it with my hand on top as I'm screwing these nuts down. And this is another reason why it's kind of nice to take the GPU out when you do this because it gives you a lot more room to work. But it depends on how much room you have around your processor in your case. You might have a little bit more room. This is a much smaller case, so it's a lot tighter fit. So it's nice to have the GPU out of the way. And the 2080 that's in this is kind of a big GPU, so it helps to get that thing out of the way when we're messing with the cooler itself. And in this case, it's actually required because the wires are routed underneath the GPU, and it would be really difficult to get this thing off with the wires still plugged in because we wouldn't really be able to move it out of the case completely. So once you get these somewhat finger tight, on the Corsair ones, they have little slots in them where you can use a screwdriver to tighten them up the rest of the way. And typically, it's not too much more than finger tight. And the way you would tighten these is the same way you would put a tire on a car. You want to go in a staggered pattern. You don't want to just tighten one screw all the way down. You want to kind of go around it so you have even pressure the whole way down. And then just make sure these don't need to be cranked down tight. They just need to be tightened until they stop turning. You don't need to actually torque them to any kind of specification. And then at this point, I can go ahead and put my wires back in. I got my RGB and my fan header itself. And then I can put my GPU back in. And that's all it takes to install. It's really not that hard to put these thermal pads in. However, keep in mind that because we put the KryoSheet in, the Thermal Grizzly recommends we never remove it. If we do, we have to replace it with a brand new pad. But if we were to have used the Carbonaut sheet, then we could have reused it with as many applications, at least as many applications as the pad survived. So now that we have the thermal pad installed, we need to see how well it actually performs. So to replicate a realistic use case for these different thermal transfer solutions, I decided to use the same testing that we used while troubleshooting the temperature issues we were having on this AM5 Ryzen. That's simply running a multi-core test in Cinebench. Now, I did get a few comments on this in my last videos from people who rightly stated that Cinebench doesn't push the processor to its full potential. And they're absolutely correct. I mean, I could use a program like Prime 95 to absolutely beat the crap out of this processor to get the absolute highest temperature possible, but that's not a realistic use case. Now, you may agree with me on this, or you may disagree, but I think as long as we do the same test with the thermal paste as our control test, we should be able to show a realistic difference between these different thermal solutions. So, with that said, let's see how they performed. Now, the first graph we have here is with all factory settings. I disabled all tweaks in Ryzen Master, and I'm running my default fan curves in fan control. I typically like my systems to be quiet, so the fan curves are pretty aggressively low and only ramp up when the temperatures get too high. As you can see from this graph, all of the different solutions are pretty close. What kind of surprised me was that the Carbonaut pad performed worse than the thermal paste by about 1 degree Celsius. Also, the KryoSheet, while it did get the lowest overall temperature, wasn't that low. I mean, it saved us about 1 degree Celsius. What surprised me even more though is the next graph. The only difference here is that I raised the pump speed, the radiator and fan, and the case fan speeds to their max settings. Unfortunately, this made the system much louder, but it did a great job of dropping the temperatures down to even lower numbers. In this case, the thermal paste beat the Carbonaut pad again, but not by that much. They were off by less than 0.5 degree. However, the performance of the KryoSheet scaled up quite a bit by lowering the temperature by 2 degrees Celsius overall. Now, this pretty much should answer our question. It looks like these thermal pads function pretty comparable to Thermal Grizzly's thermal paste. However, the KryoSheet really does perform better. Just not that much better, but a win is a win either way, right? However, I wanted to push this test a little bit further to see how well these thermal pads work after being removed and reapplied. Now, the Carbonaut pad claims to be reusable, so obviously we need to test that to see if it is in fact true. But I also wanted to know what would happen if we tried to reinstall the KryoSheet as well. Does it lose performance on its second application? Now, originally I tested the Carbonaut sheet first, and then I switched to the KryoSheet. After I tested the KryoSheet, I removed it from the system, put it back into its box, and I put the KryoSheet, Carbonaut rather, back in the system and tested it again. Then I flipped back over to the KryoSheet again, put it back into the system and tested it for a second time. So let's see how they did. So in this first graph, you can see that the KryoSheet does give a much better result with an average drop of 1.5 degrees Celsius. However, when we flip over to this graph, these are the temperatures that we got after reusing both of these thermal pads. The difference isn't so much. In fact, they look like they perform almost the same, with the KryoSheet being just barely lower than the Carbonaut. But if we switch over to this graph, which shows the first and second applications of the Carbonaut, we can see that it lost almost no efficiency on its second use. In fact, if we were to get technical, it looks like it performed just slightly better, but it was still well within the margin of error. However, when we flip over to this graph, which shows the first and second application of the KryoSheet, we can see we lost quite a bit of efficiency. In fact, we lost an entire degree Celsius. So it looks like the recommendations are pretty good from Thermal Grizzly. The KryoSheet is only one-time use, but if you look at the temperatures that we got, the KryoSheet still slightly outperformed the Carbonaut pad on its second use. So all this really tells me is that for whatever reason, you lose the benefit of the KryoSheet by reusing it, but it'll work just as good as the Carbonaut if you get forced to reuse it. So if you were in a situation where you had to pull the cooler off for whatever reason, you could probably reuse it until you had time to order another one. But here's the thing, reusing these thermal pads in both cases is based on the fact of whether or not they stay in one piece when you take your cooler off. All of the testing that I did was done on a single afternoon. So these sheets did not spend an extended period of time in my system. At most, each one spent a couple of hours installed. So if you use one of these sheets in a system that you use on a daily basis with heating and cooling cycles, the likelihood of it not breaking apart when you pull the cooler off becomes considerably lower. Both of these thermal pads are very delicate. In fact, the KryoSheet is extremely delicate. If you tear these sheets, then all you're going to do is create voids between the cracks in the sheet that are going to make the thermal pad irrelevant, because those cracks are just going to create air pockets that don't transfer heat. Remember, it only takes microscopic voids to hinder thermal transfer. That's the reason why Thermal Grizzly doesn't recommend using the KryoSheet to begin with. Because by reusing them, you can actually create microscopic cracks in the sheet, hindering its thermal performance, which we definitely saw in our tests. I mean, even though I didn't see any visible cracks in the sheet, that doesn't mean that the sheet wasn't damaged microscopically. I mean, something changed for sure. And this also goes for the Carbonaut pads. If you accidentally tear it, then it's garbage. Don't reuse it. So ultimately though, I don't see a benefit thermally to using thermal pads instead of thermal paste. Yes, the KryoSheet got slightly better temperatures, and if you're looking for the absolute best temperatures that you can get, then use it. But for the price, I still think that thermal paste is a more robust solution. However, if you really like the idea of having a reusable thermal pad that isn't messy as thermal paste, then the Carbonaut pad is a great option, even though it slightly performed under the thermal paste ultimately. But you know what? I wouldn't discourage anyone from using any of these solutions. I think they're all great and they all have their place. You just have to decide which downside you're willing to accept for the benefits that you get. For me though, I think I'm just gonna stick with thermal paste. Yes, it's a pain to clean up and it requires reapplication occasionally, but it's universal and it's cheap. But with that said, if you really want to lower your temperatures, and I'm not talking about 1 or 2 degrees here, then check out this video where I show you how to drastically drop the temperature and increase the performance of an AM5 Ryzen by just tweaking a few settings. As always, you guys have a great day.